Hello everyone, my name is Hemlata Mediboina and my topic name is Classification of Data Structures. Firstly, we'll understand what is data structure. A data structure is a storage that is used to store and organize data. It is a way of arranging data on a computer so that it can be accessed and updated efficiently. Here, the data structure is classified into two types, primitive data structure and non-primitive data structure. Primitive data structure. Primitive data structures are the basic data structures that directly operate upon the machine instructions. They have different representation on different computers. In primitive data structure, it contains basic data types like int, float, boolean, char. Non-primitive data structure. Non-primitive data structure are those data structures derived from primitive data structure. The focus of these data structures is forming a set of data elements that is either homogeneous, that is same data type, or heterogeneous, that is different data type. Non-primitive data structure is further classified into two types, linear data structure and non-linear data structure. Linear data structure. In linear data structure, data elements are arranged in a linear order. For example, array, linked list, stack, and queue. Nonlinear data structure. In nonlinear data structure, the data elements are not arranged in a sequential order. For example, tree and graph. Nonlinear data structure is further classified into two types, static data structure and dynamic data structure. Static data structure. Static data structure has a fixed memory size. The memory for this data structure is allocated at the compiler time and their size cannot be changed by the user after being compiled. The array is the best example as the size cannot be changed and its data can be modified later. Dynamic data structure. In dynamic data structure, the size is not fixed. The memory for this data structure is allocated at the runtime and the size varies during runtime of the code. Linked list, stack, queue are few common examples of dynamic data structure. In static data structure, we have arrays. An array is a collection of similar data types, and each data item is called an element of the array. The elements of array share the same variable name, but each one carries a different index number known as subscript. The array can be one-dimensional or multi-dimensional. The size of the array is fixed. In dynamic data structure, we have linked list, stack, and queue. We'll understand this one by one. First, linked list. A linked list is a linear collection of elements called nodes. Each node in the linked list contains two parts, the data and link to the next node. Linked list is a linear data structure which is used to maintain a list in the memory. It can be seen as a collection of nodes stored at non-contiguous memory locations. And the second one is stack. Stack is a linear data structure in which insertion and deletion are allowed only at one end is called the top. All the deletion and insertion in the stack is done from the top of the stack. The last added element will be the first to be removed from the stack. This is the reason why stack is also called last in first out type of list. It follows LIFO technique, that is last in first out. A stack is an abstract data type can be implemented in most of the programming languages. And the third one is queue. Queue is a linear data structure in which data can only be inserted at one end called the rear and deleted from other end is called the front. It follows FIFO technique, that is first in first out. It is an abstract data structure similar to stack. In nonlinear data structure we have tree. Tree is a nonlinear and hierarchical data structure where the elements are arranged in a tree-like structure. Trees are multi-level data structures with a hierarchical relationship among its elements known as nodes. The bottommost node in the hierarchy are called leaf node, while the topmost node is called root node. Tree data structure is based on parent-child relationship among the nodes. Each node contains pointers that points to the child node. Each node in the tree can have more than one children except the leaf node, whereas each node can have at most one parent except the root node. And the next one is graph. A graph is a nonlinear data structure that consists of vertices or nodes and edges. Graphs can be defined as the pictorial representation of the set of elements represented by vertices connected by the links known as edges. A graph is different from tree in the sense that a graph can have cycle while the tree cannot have the one.